Hello, friends. We are going to let the fun continue with some day two action on 13.3. This one is a doozy, not terrible, but this is one that's going to utilize parts of your brain that you may have been ignoring here on quarantine. We're going to start getting into something called the unit circle and relating the triangles, ironically, that we're working on with the unit circle. So who knew that a circle was made up of triangles? So we're going to start practicing some of the math and some of the vocabulary. The math today is fairly easy. I would say that your process each time should be that you're going to draw a triangle, and it's going to always be a right triangle. I always say it's part of the bow tie, and this will make sense as we go through the examples, meaning it either is up here with the right angle out or down here, right angle out, in quadrant 2 with the right angle out, or quadrant 3. So all of your triangles should be a part of that bow tie. Then you should label all the sides. So opposite, adjacent, hypotenuse, so you kind of know what you're looking for. You will only ever know 2 out of the 3 sides, so you'll need to use a squared plus b squared equals c squared to find side 3. And when you do that, you're going to have to think about plus or minus depending on which quadrant it's in. Once you've done all that, you'll be able to go ahead and answer the questions. So I know that right now I'm the only one that has any idea what that means, but I'll refer back to it as we go. So this is just a quick reminder that when you find the sine, you're going to be finding the opposite over opposite over hypotenuse. So let's go ahead and draw in a triangle over here that we're going to use. In this triangle, this is a point. Like you went over x and up y to get there. So that has coordinates of x and y, just like we've graphed since forever. Our angle is down here in the little corner that is attached to the x-axis, the reference angles that we talked about yesterday. And then this is going to be, like for me to get to that point, I went over this far. That's my x coordinate. And then I went up this high, which is my y coordinate. Now keep in mind that, yeah, in quadrant 1, my x and y are both positive. But to get into quadrant 2, when I'm dealing with one of these triangles up here, to get into that quadrant, keep in mind that you would have a negative x and a positive y. To get down here into quadrant 3, keep in mind when you go to do these, and this is what I'm talking about with thinking about plus or minus, to get into this quadrant, I'm going to have both a negative x and a negative y. And to land in quadrant 4, I'd have a positive x but a negative y. So you want to keep track of that because it's going to be your job to decide if your values are positive or negative based on which quadrant you're in. So this is going to be the radius of the circle right here. But the beauty of our circle that we're going to be dealing with is called the unit circle. So the radius of our circle is going to be 1. So this triangle in this circle, my sine, which remember is opposite over hypotenuse, well, this would be the opposite side. This would be my hypotenuse, and this will be my adjacent. So the sine would be opposite over hypotenuse, which is going to be my y coordinate over my radius. But since our radius is 1, my sine is really asking for just the y value. Okay, well then the easiest thing to find once I know the sine is the cosecant because those are reciprocal pair. So that means that my cosecant will just be the reciprocal of that, and I would end up with my radius of 1 over my y coordinate. And so basically I'm just going to flip over the y coordinate to get my cosecant. Same thinking here, cosine is adjacent over hypotenuse. So in my picture, the adjacent is the x, and the radius is a 1 because we're using a unit circle where the radius is 1. So x over 1 is just going to be x. So when you're asked for the cosine, you're being asked for the x coordinate of the triangle that you've drawn. The secant is its reciprocal partner, which would take that and flip it over. So my radius would be 1 and my x coordinate would be on the bottom. And so the secant, the thing I can do easiest is just flip over my x coordinate, and that will give me my secant value. Looking at my triangle, the tangent, which is opposite over adjacent, would be my y coordinate over my x. So the tangent of theta is going to be a combination of y over x. Keeping in mind that you flip that over to get cotangent, my cotangent would therefore be x divided by y. And that can get messy because you might have to do some rationalization and that kind of thing, because you always want to make sure that you have simplified, that you have rationalized your answer if needed. Okay, so the math on this is really easy. The only time it gets a little messy is when you have to deal with the radicals. So let's go back to my process. Draw a triangle, label it, use Pythagorean theorem, and then I can answer the question. So let's see how that looks. Here's my XY point. So I'm supposed to go back 1, 2, 3, 4, up 1, 2, 3. So I connect that point back to the origin, and that's how I generate my right triangle from that little bow tie setup. That is the key thing, is to draw that triangle. Then I'm going to label this and this side because those two I know. I also like to label them adjacent and opposite and hypotenuse so I don't have to think about that later. Okay, so I drew the triangle and I labeled my sides. Now I'm supposed to use Pythagorean theorem to find side 3. So I don't care about the -4, and I actually usually don't even write it, because when I go to square it, it's going to turn positive anyway. Now this one's going to be pretty user-friendly because I get a C value of just 5. And I know normally when we're solving we have to do plus or minus, but since that's measuring how long this is, it can't possibly be a negative number. The reason this is a negative is it's telling you the direction to go. So it's not saying that the side length is -4, it's just saying the direction is negative. The hypotenuse is never negative on these. Okay, so now I have everything I need. So the fact that I labeled everything makes the actual answer super easy. So I think, okay, sine is opposite over hypotenuse. So in my triangle, that's 3 over 5. The easiest thing to do next is cosecant because I just flip that over. Cosine, my adjacent side over hypotenuse. So looking at my picture, that's -4 over 5. Easiest thing to do next is secant because I just flip that over. And you can put the negative anywhere. It can go on the top, the bottom, out front. I usually just leave it on the top because it looks weird on the bottom. Tangent, opposite over adjacent. So looking at my picture, that's 3 over -4. And the cotangent will flip that over, so I'd have a 4 over 3, but it's still negative. So that's the process. Draw the triangle based on the endpoint. Label the opposite adjacent hypotenuse so you don't have to think very hard over here. Find the third side using Pythagorean theorem, and then you're good to go. But it can get messier. So I want to have an example where it's not just like, oh, 3, 4, 5, that's pretty. Good luck on your homework. Let's take a look at one that has some simplifying and rationalizing involved. So now I'm going to graph 6, 1, 2, 3, 4, 5, 6 on the x, and then down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So I went out 6 to the right, and then I go down 12 because it's negative, and then I connect my endpoint back to the origin. So there's my theta, or my little reference angle, and then my right angle's out in the corner because then I'm looking at this kind of part of the bow tie. Then I'm supposed to label. So if this is my angle, this is going to be opposite, adjacent, hypotenuse. So easy. Now I'm supposed to find that hypotenuse. So to do that, I'm going to need a 6 squared, a 12 squared, and again, I don't use a negative because I don't want to mess up, and I also know that the 12 is the length. The negative is just telling me which direction, and that's going to help me find c squared. So where am I going to be at? This is going to come together as 180. So then I'm going to need to square root that. So here's the problem. I have the square root of 180 and I can't use decimals. So I have to think like what perfect squares go into 180. So if you start, you want to start with as big as you can think of. So if I have 180, 25 doesn't go in there. I don't know if 16 does. I'm going to start bigger. So I'm going to start like, let's say I want to start 64. Oops, let's say I took 180 and I want to check. Does 64 go in there? No. What if I take 180 and I try 36? I keep making that mistake. So 180 divided by 36. Boom, awesome. So if this breaks into 36 and 5, that means my hypotenuse is going to be 6 root 5. And we're in big people honors math, so that's, legitimate. It's going to happen to us. So this side is 6 root 5. Okay, so this whole simplified and rationalized thing is going to come into play big time now, because when I go to do, try this. When I go to do my sine, I'm thinking opposite over hypotenuse. So that would be negative 12 over 6 root 5. So negative 12 over 6 root 5, and I'm not putting it in my answer spot because I'm not done. The first thing I see I can do is I can reduce these two because they're on the outside, so that would turn into negative 2 over root 5. This is the moment where I flip this over, because right now if I flip this over for cosecant, I'll have root 5 over 2, but that whole thing is negative. Because if I wait until I've rationalized it, then I flip it over, I'm going to end up having to rationalize it again. So I like to flip it over before I rationalize it to get this answer. Now, let me rationalize this. I've got to multiply the bottom and therefore the top by root 5. So I end up with negative 2 root 5 over 5. And the 2 and the 5 don't reduce. So I end up with negative 2 root 5 over 5 in that spot. Okay, how about cosine? I take my adjacent, I'm going to write it down here. So my cosine is going to be my adjacent side, which is 6, over my hypotenuse. Well, let's start simplifying. That can cancel. So now my cosine is 1 over root 5. So this is the moment when I'm going to decide to flip over my answer. So my secant would be root 5 over 1. And now I'm going to come back and finish up my cosine answer by simplifying. So this turns into a cosine of root 5 over regular 5. So here's my cosine value. Now keep in mind, these guys are reciprocal partners. So if your sine is negative, your cosecant should be negative. If your cosine is positive, the secant should be positive. These partners should never have opposite signs because you're not doing anything with the negative or positive, you're just flipping the numbers over. How about tangent? Tangent turns out to be one of the easier ones because when I do opposite over adjacent, I get negative 12 over 6 from my picture, and that reduces to negative 2. But then if I flip that over, I would have had 6 over negative 12, so I'd end up with negative 1 over 2 because the reciprocal of negative 2 is negative 1/2. So these can be super straightforward, and this looks a lot harder, but it's just messy in terms of getting your answers simplified and rationalized. So there is a worksheet. It is not due today if you're working on this Friday. It's going to be due sometime on Monday, and I'll probably send out an update to push that back a little bit, give you a little more time so that you don't have to worry about it over the weekend. It's currently due at 10 in the morning. I'll probably change that time to 5 at night. So that way, if you don't want to worry about it until Monday, you don't have to. Have a great weekend, and I will see you guys Monday in the classroom. If not before, you're welcome to ask me any questions Thursday and Friday. See you guys later. Bye-bye.